timing.
Can we watch Bill?
We're going to start by. Let's label this specific forces. Specific forces. So in the previous lesson, we talked about what I would call. We talked about what I would call forces in general. We talked about net force. Do you remember that?
Yep.
How when we add up forces together on an object, that's called the net force. Do you remember that? What else did we talk about? We remember.
We talked
about contact and non-contact forces.
Contact and non-contact
Yes, we talked about contact and non-contact forces. And we talked about what forces cause. What do forces cause? Unbalanced forces. Net forces cause.
Net
What?
forces cause regular forces.
No. No.
Net forces cause unbalanced.
No. They cause a change in motion. What was the code word we used for change in motion?
Acceleration.
Acceleration. So write that down somewhere, because not everyone knew that. Write it down.
Was it
net forces? Let's remind ourselves that net force cause acceleration. Net forces cause a change in motion. And we talked about how, what's another word for motion? When we describe motion mathematically with a direction, we call that what?
Mr. Patrick,
When we describe motion mathematically with a direction, we call it what, Faith?
When you said mathematically, I forgot.
When we use numbers to describe the motion.
Change in motion?
Something meters per second. We call that a...
Oh, newtons.
No.
What? Something.
We talked about this.
millimeters.
Velocity.
Velocity. I think it's velocity, Mr. Trent.
Can I sharpen my pencil?
A way of describing motion is velocity. And when the velocity... Don't interrupt me. Yes, that's fine. When velocity changes, that's called
Acceleration.
And acceleration is always caused by net force. Net force. We had talked about if we have an object, in this case a birthday present, if we have an object that has these forces acting on it, a force down,
Gravity.
and a force up. You remember what we call the force up that holds it up from falling through the floor?
The ground.
Neutral.
Balance.
Normal.
Ah.
Normal force. You need to remember that too. The normal force. When these two forces, yes, together they are, the net force here is what?
Balance.
It's balanced, so what number is it equal to?
0.
0. They're in opposite directions, and so they subtract, so they're 0. So is there a net force? No. So is there acceleration?
No.
No. There's no acceleration. Remember, the acceleration is a change in motion. Does that mean it has to be stopped?
No.
No. It could also be doing what? We talked about
Going in
balance.
a straight line at the same rate of speed.
Exactly. It could be going in a straight line at a constant speed, but velocity is not changing, so it's not accelerating because there's no net force. Do you see how these three things relate to each other? Boom, boom, boom. Those things, you have to know how those relate to each other. Velocity, acceleration, and net force. That was what we talked about previously. We talked about this. We talked about what forces are in general. We talked about contact and non-contact forces, and we drew diagrams for forces. You remember all that? Does anyone need any more reminders of how that worked?
What's the definition of velocity?
Velocity is motion described mathematically, I would say. We could say that it's a speed and a direction. That's how I usually describe it. So what are some specific forces that can happen? Well, we have two here. F sub g, the force of gravity, which is equal to an object's weight. So let's write that down. Gravity. What else? No, not super specific. What else do we have on this diagram even?
There could be air resistance.
Yes, there could be, but on this diagram there is.
Gravitational.
There is. We already wrote that down.
Normal force.
F sub n, which is the normal force. Force supporting an object. You're sitting in a chair. What kind of force is the chair applying to your caboose?
Gravity.
No,
There's a normal force because
The normal
the chair isn't going to go
the
through.
normal force. What could you sit on that would not provide as much normal force such that you did fall through it?
Paper.
Styrofoam.
if you had, or an empty cardboard box maybe. We can think about an empty cardboard box. If you sat on it, it is incapable of supporting you because it can provide less normal force. And so you go through it. The force acting on you, the normal force would be weaker, right? And so then you would be overcome by gravity and you fall through. Does that make sense?
Don't weigh that much.
So the net force would no longer be 0. Sorry, that's moving through there. Unless you don't weigh that much. Yeah, because it depends on the weight of the object versus the normal force. Let's check this out.
Check it out.
Look. These papers have a certain weight, don't they? Do you see them?
Yes.
They have a certain weight. This is providing a normal force to them, so it's
Yes.
supporting. Yeah? So far so good. Is it balanced?
Yeah.
Yeah, and we can tell because it's not,
Fine.
it doesn't always have,
Accelerating.
it's not
Going
accelerating.
down.
Its motion is not changing, right? Its motion is not changing, and so we know the forces acting on it must be balanced. I think this book might not work.
You're gonna
Okay,
have a
yeah,
textbook.
grab me a textbook. Just give me one of your heavier textbooks. But the point is here that as I apply more weight, the certain amount of normal force that this, you see that? The normal force was no longer able to support, or at least the normal force provided by this cylinder was no longer able to counteract the weight, so the normal force was less than the weight, and so it fell. Right? Does that make sense?
Yes, sir.
So we have gravity, what do we call the force of gravity acting on an object?
Wait.
Weight. We have the normal force, which supports objects. What other kinds of forces are there specifically? Look in your explorer. Oh, you don't have that.
Accelerating.
Never mind. I'm going to tell you. Yeah. What's another one?
There's magnetic forces.
Oh, okay. Hold on. Well, we're gonna do these one at a time. We'll call that F sub m. That's not always what F sub n means. We'll call that the magnetic force. Sure. And we're going to talk more about that in Unit 2. What else? What other kinds of forces are there that act on objects?
Unbalanced.
That's too general. You said one earlier that isn't too general, though. What was it? You said it. You.
Me?
Yes, you.
Oh, okay, I don't know.
Did anyone remember what Hunter said?
Air resistance.
Air resistance.
Oh, air resistance.
F sub, I'm going to call it F sub lowercase d, which is drag, which is air resistance. We use these terms interchangeably. Obviously, drag would apply to any fluid,
Dr. Pepper.
even Dr. Pepper. But when we say fluid in physics, do we mean, if your doctor says drink more fluids, he probably specifically means water, maybe juice, maybe like chicken noodle soup, but he probably doesn't mean kerosene. But kerosene is a fluid in physics. A fluid is anything that flows in physics. Air is a fluid. Natural gas is a fluid. Gasoline is a fluid. But any kind of fluid resistance, we call the force supplied by that fluid drag. Yes.
We actually learned a lot about this in shop last year.
Oh, good.
Like if you did like
Because of the little car.
if you did
designed.
the cars, you
Yeah.
learned a lot about drag and air resistance and that.
Perfect. Good. I'm glad that you did that. So you have some familiarity with it.
Yes.
What's another specific? Not specific, but specific. I'm looking for one more specific force. Friction. That's what I'm looking for.
Say
That's
that.
exactly what I'm looking for. F sub lowercase f is friction.
You said E.
F sub G.
This was F sub g. This is F sub lowercase
I
f.
thought that was D.
Riz.
It's
This
not
is-
really related to force, but can I ask a scientific question?
Not right this second. Let's wait till the video's over. You can ask whatever questions you want. If it's specifically related to this, I want you to raise your hand and we're going to talk about it while we talk about this. But in the meantime, or if it's not related, let's wait till after the video's over so that those who are watching at home do not have to suffer through it. Okay, so we have several kinds of specific forces here that we're talking about. We're going to start by talking about the force of friction.
I just made friction with my shoes.
You're making friction all the time, but let's define friction. This is a force that does what? What does it do?
Makes things slow down.
Okay,
Makes
that's a good rudimentary
lesser
definition.
accelerate.
Okay, it's actually still accelerating if it slows down. That's still acceleration.
It makes things slow.
Honestly.
Make stuff stop.
It can cause things to come to a stop.
It causes things to slow.
It causes. Look here. Look here.
It causes some things to not move at all.
Yeah, not move at all. So it's a force that does what to motion?
Everything.
Does everything to motion?
Force that.
Makes it not stop.
Makes it
Makes
not
it
happen.
decelerate.
Makes no motion happen.
What verb goes here? What verb goes here? Force that does what to motion? I'm looking for something
Not
specific.
That
motion.
makes-
Does not make motion.
And
Push.
Does not make motion.
puts a stop.
I'm going to put
to
opposes.
opposes. Sure.
Like it acts. This means I use this word specifically because it acts in what direction? Acts how?
Against
Yeah, in the what direction?
accelerating.
In the what direction? That is the
Opposing direction.
Yes, what we call the
Opposite.
Yeah, act in the opposite. Who wants to be in the drawing?
Me.
Me.
Kesslin.
Kesslin.
Me. I don't know.
Chloe.
I'm in the video.
Me too.
This is basically Kesslin's hair color.
Poop brown.
It's like reddish brown. Okay. Anyway, Kesslin is pushing on a box. She's applying. We're talking just about the box, not Kesslin. We're talking about just about the box. She's applying a push force, F sub P, to the box. Okay. It's not moving. Okay. She's applying a push force. If it's not moving, what do we know? Is it accelerating?
No.
No. Its motion is not changing, and so it's not accelerating. So what must the net force be?
No. Zero.
Zero net force. So if she's putting this push force on the box, what force of friction must be opposing her?
Drag.
It's still friction force.
Oh.
I'm not talking about for the kind of force.
The
I'm looking for
gravitational
how
force.
does the length of the arrow, how does the magnitude of the force of friction compare to the magnitude of the push force she's applying? They must be.
It's heavier. There's more
They're the
gravity.
same, but
What?
the same length of arrow, but how? Should I just draw on top?
One might be
No.
heavier.
It must be in the
Opposite
opposite
direction.
direction. Whoa, that's not really a straight arrow. Let's try again.
That's
There.
straighter.
The F sub F. So what's the net force here?
Not-
Zero.
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 Net force is 0.
So is that an unbalanced
Now, what
force?
if you draw me? I'm a
No,
big
this is a
strong
balance
guy.
force.
What if you draw me because I'm a big strong guy?
Because it's
Oh, is that why?
Okay, what if
Mr.
Gunner comes up and he's gonna help push it?
Is that why Mr.
Then,
Gunner does.
then there would, then there would
I didn't mean to do
be
that, but it is true. Let's put a
then there
bullet on
would
him.
be enough.
Oh yeah.
There we go. So he adds another push force, and so now we have twice as much push force. It does start to move. But does it keep moving faster and faster forever? Does it accelerate forever? No, eventually the faster they move it, the stronger the force of friction gets. And so now even though it's moving, they've started it moving, eventually the friction force gets to be the same too. And does it stop right away? No.
It slows
because
down.
It slows down and eventually does what?
Accelerates.
It doesn't stop. We're going to say that instead of accelerating, which it does accelerate at first, but eventually it's moving in a straight line at a constant speed.
Oh, so
And what is the net force then?
Then
it's normal force.
0 net force still. Okay? Even if it's already
Same.
moving. Yeah. Even if it's already so they accelerate a little bit to start with, and then friction catches up with them, and it
Then
doesn't
the-
move.
Then the friction.
It's still moving,
Same.
but it doesn't get any faster or any slower. And then if they stop pushing it, what happens?
Then it's
It stops because friction is now much stronger than the force they're applying.
If there was,
Gunner's actually
He raised his hand.
I think Gunner's actually worth 2 arrows.
No, you could push harder, but you're not. You're kind of lazy. Okay, Hunter, you had a question.
if there was 0 friction on that box, if you just like went like that, it would move.
Yeah, exactly. If there were no friction, you could. If this had no friction, I put the tiniest force of my breath on it, it would move.
Really?
Yes. So let's talk about that next. How can we reduce friction? Keston, you have a question. Let's hear it.
Well, I just had something. Well, yeah, it's kind of a question. Is that why since there's friction and it's a balanced force that there's no net force that
Yep.
it's 0?
Yep.
Okay.
Friction. Give me a second, please. Too many questions. Friction depends on. I want to answer your questions, but I want to do this first. Friction depends on 2 things. How hard. That was almost fart. How hard the objects are pressed together. This is a simplistic definition for 8th graders. If you want to learn more, I literally just told the physics boys about this. If you want to learn more, you can watch the video I made for physics 20 minutes ago. How hard the objects are pressed together, and what would be the other thing that depends on? How else? So what's pushing these 2 objects together?
Normal force and gravitation.
Yes, exactly. Thank you for including the normal force. The normal force and gravity are pushing the floor and the Promethean together, right?
Yeah.
So how hard they're pushed together is one thing, right?
Okay.
This
Does
is
that
pushed,
make it-
because this weighs less, it's pushed together less, and so I can move it more easily. What else depends? What else could we change that would make it have either more or less friction? How what the surfaces are. I'm gonna write that.
The
How
surface.
rough.
Yeah, there we go. I've done the smooth, but you're a glass half empty kind of guy, Gunner. So how rough the surfaces are. How rough the surfaces are.
What's
Did
that
you just
first
roast
one?
me, Mr.
What's up?
What's the first one? How
How hard the objects are pressed together. So do this. You can do it. First of all, what do you notice is happening to your hands?
Friction, they're warming up.
They're warming up because that's what friction does. Friction changes motion into heat energy. We'll talk more about that when we talk about energy. But also, if you press them really hard together, like enough that your arms are shaking, can you still slide them as easily? You can slide them, but not as easily, right? How can we make it easier to slide them? Either we could lay off a little, or we could reduce it. How can we reduce the friction though? We could either not press them together so hard.
Just do your fingertips.
Apply it. Okay, so we can apply less force, not push them together so hard. How else could we do it? Yeah, we could put some lotion on, which would do what?
Lubricant.
It's a lubricant. That's exactly right. So we're going to write that down. A lubricant is an object that basically it smooths out the rough surfaces to make it so there's less friction. Lubricant smooths out rough edges. And actually what it doesn't smooth them out, it kind of fills in the gaps. Fills in. So instead of the object's little roughness touching roughness, instead of that, there's a layer of usually oil, but some kind of fluid in here that prevents them from actually touching. So how can I make the Promethean easier to push?
Put some lube on the floor.
Yeah, exactly. What could I use?
Butter.
Butter. We usually use oil. Yeah, some kind of oil based. We could use soap.
Right?
Yes.
Can I ask a question?
We're talking about that in a second. Yes.
Gravity and stuff. So Earth has a normal force.
We're getting to gravity. We're going to get to gravity after we talk about friction. So
Okay.
Will said something interesting though. What's one way I could push this more easily?
Unhook.
If I unlock the brakes, what that does, listen to this.
That makes
Write
the
this down.
wheels turn.
Yeah. So it switches it from, there are really three very broad kinds of friction. There's what we call static friction, which is where the objects are staying still. Static comes from the same word as stay. Static friction.
So like, if
What about like TV static?
So if we put
Objects.
lubricant there.
Give me a second, please. Staying still. Please stop talking for a second. Please stop talking for a second. TV static is called that because it's the way the signal stays when there's nothing else going on. Static friction. So static friction is when objects are staying still. Sliding friction, which is what we've been talking about so far. Rolling friction. And then there's also something called fluid friction, which is the same as drag that we already talked about. But this rolling friction, almost always, I can't think of any example when this isn't true, but the sliding friction is almost always greater than rolling friction. So for the same two surfaces, the wheels will say they're rubber, I don't know what they actually are, but for rubber on wood, the sliding friction of rubber on wood, we'll say, is 1. The rolling friction of rubber on wood might be 0.8. It's always less. It's not always a lot less, but it's, I wouldn't even say it's always. But in almost every case, it's less. Static friction, sliding friction, rolling friction, and fluid friction. Thanks, Kelly. If I'm pushing on it and it doesn't move, is friction acting on it?
No.
Yes.
Try again.
Yes, actually, yes.
I'm pushing on it and it doesn't move. So there must be friction. What kind of friction out of those?
Still friction.
Static friction.
Static.
If I push on this and it does move, what kind of friction is that?
Sliding.
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 Sliding, because it's nothing's rolling
Just
there.
start with-
If I take the brakes off of there, then it'll be rolling friction. And what I'm actually doing, if I lubricate this, if I put
Fluid
lubricant
friction.
all over the floor, it's really making it into fluid friction instead. Okay? Questions about friction before we move on?
Yes, I have a question.
Yes.
Like who thought of that?
It's just all true. It doesn't. Hey, Hunter, you've had this problem a couple other times. This is not made up stuff. This is I'm making up the way I'm describing it to you. And people made up laws about this, but it is literally the way the world works. You could go to any planet in the universe, and whatever critters that live there would have a way of describing it. It might not be the same as the way.
But someone had to think about it and why.
Yeah, but it's just true. This is all the way we explain it. I just thought of this, right? I got a little bit of it from your book, but I just made this up. But it's all just the way it is. We use the same terminology. These vocab words came from your textbook because I want to use the same terminology that the rest of humanity agrees. Basically, we agree on the way to describe it, but it's a true thing. It's just a fact of nature. That's what science is all about, is the fact. You're confused because you're thinking about on Facebook there's someone's grandma is talking about one side of whether vaccines are real and someone else's redneck uncle is talking about the other side, and it seems like they're both presenting arguments. But we can't argue about this because this is just the way it is. It doesn't matter what you believe about this. It's the truth. What we might disagree on is the ways we describe it, But this is just vocab to describe a true physical thing that actually literally happens in the physical universe.
Can I say something though? Like, someone had to think about that really hard though, like sliding.
The vocabulary?
something. Like, no, but like sliding. Someone had to make like millions of definitions.
Oh, no, well, it's just, they're just easy. These are just easy words to describe that we all agree on. Yes.
Okay, so let's take this crumpled ball of paper.
Go ahead and give us an example.
When I roll it, it kind of moves, but like it also slides as it rolls. So would that be
It's probably
sliding
both.
friction or rolling
And
friction?
really what it's doing, for the force that Gunnar applied, he's saying that this little thing is sometimes rolling and sometimes sliding. So for the force that he applied, and depending on which surface of it is touching, either rolling friction is greater or sliding friction is greater. So once again, several times I misspoke and said sliding friction is always less than rolling friction. That's not always true, but most of the time it is. And so sometimes, depending on the surfaces, sometimes it's easier for it to roll, sometimes it's easier for it to slide, and when you apply that force, it depends on which one, and really, what I could find, the more you're doing it, what it actually depends on is which surface of the rolled up thing. So if you have this surface touching it, it's easier for it to slide than roll. If you have this crumbled up bit touching it, it's easier for it to roll than slide. It just depends. Okay, let's move on to gravity before we run out of time. Just so you know, from this you need to be responsible for knowing the kinds of friction and knowing what friction depends on, okay?
Will
You
it
should
be on
know-
the test?
Yes, of course it will. You should know more. You should know about lubricants and how all these kinds of forces act together. But this is the stuff that is the easiest to learn and the most likely to show up on your test. Types of friction and what friction depends on.
Wait,
Okay?
so it's-
And therefore, how we can. It doesn't matter. Just know it. It's a vocab word that I'm telling you to know. How can we reduce friction and how can we increase friction are two of the things you're going to have to do. So now we're going to shift gears here to, instead of talking about friction, which is what we were talking about, we're now going to talk about gravity. So write that down, please. Okay.
Pardon the interruption. Bo, Hank, please come to the music room. Bo, Hank, please come to the music room. Thank
Oh,
you.
the superintendent. How are you saying Bo?